Now I'm going to start my sharing of introduction to macOS reversing. So before I start, I want to let you guys know that I will present this sharing as if you guys already know the basic of RE, since I'm just gonna relate and compare macOS environment with the Windows environment. But for those who are not, I still hope you can get something from the sharing. So my name is Riven. My real name is Hafiz. I'm a hardcore RE player. I only play CTF to hunt their RE challenge. And my focus are, of course, the reversing. But now I'm going deeper into the kernel exploitation for more specific kernel anti-cheat. So beside RE, my next favorite is the forensic or BFIR. Actually, I left the reversing of Apple environment quite sometimes due to focusing on the anti-cheat. But I did this sharing due to the request of MF Grip or his other name, Pada Jamil. Oh yeah, so I'm still studying in UKF. So what will we cover? So before we start, first we will go through the macOS architecture layer to show you how different it is from the Windows. Then we'll go deeper into the kernel layer, and last layer, the hardware layer. For this hardware layer is where you guys can see the difference of the assembly. Then after that, we'll go through the macOS file format and understanding of its structure together with the memory layout. And then lastly, I will talk about the security, what tool will be used, and the real world use case. Yeah, so I hope we can finish early so I can do demo. So this will be more on the theory side. So bear with me. Okay, so what are we reversing actually? So we are reversing a macro binary. So this macro is used across Mac OS and also iOS. So we reverse to understand the behavior without looking at the source code. Yeah. Okay, so what's the difference in Mac OS and Windows reversing? So all this I will not explain deeper since we'll go uh, we'll go later. So both are hybrid kernel, except macOS is a combination of Mac and BSD. Next is their file format. So while Windows use PE and Linux use ELF, macOS also got their own called the macro. Uh, we do know that Apple are known for the security, even so that can restrict a privileged user or root from modifying the system. Then the strict signing for unsigned app, Apple checks where does your file was downloaded from, and then slap a tag which user need to approve to run it. And lastly, macOS doesn't have the registry hive like Windows and doesn't support much tool like most of the tools are paid, and it's one of the reason I left the macOS reversing. It's paid to win. Okay. So for this slide, we'll go into the architecture layer. Actually, this one is old architecture. I can't find the recent one, which got the Apple Intelligence layer and so on. But never mind. Yes. So the top layer is of course the user space, which handle all the user application like the command line and driver kit. Oh yeah. Speaking of driver kit, macOS force all the driver to run no other than in the user space. Unlike Windows, you can put a driver in the ring 0, with of course the permission of Microsoft first. And then the second layer, which I compress into just the core layer, since don't have enough space. So this is where the Apple put their building block, so named Coco, which got the button, the menu, Windows, yeah, and Metal, their graphics. So this layer is also what translate the developer apps instruction into the low level so they can understand. Then the the third layer is the low level called XNU kernel. So this XNU stand for X. It's not Unix. So it's just a joke from Apple, since they actually took both a standalone project like Mac, and which is a kernel project, and took a standalone OS named BSD. So this BSD, they strip away the core and just glue it directly to Mac, and yeah, kids. That's how XNU was born. Then later from XNU, Apple create Darwin, which also include the kernel and also the IO kit. So this IO kit is how this Darwin talk to the hardware layer. Right. Yeah. So this is the more specific structure on the left, which I already explained before, except it doesn't have the hardware layer there. Right, then continuing to the next slide. So this is where we meet again, the hardware layer. So as you know, macOS got two different processors, which can either be Intel 64 or ARM 64, the Apple Silicon. So this both processor is um, like langit dengan bumi. Since first is the architecture. So for this, I leave it first, since next slide we got the picture, which can be understood better. Second is the register. So as a reverser, you must know Intel register is the register got the REX, RBX, RCX, and so on. While ARM64 register is named by number like X0, X1, X2, and so on. So by this, you can already know how assembly later looks like. And then we got the both processor employs distinct hardware level protection. For example, um, both Intel and ARM use ASLR and DEP to prevent memory corruption, while additionally, ARM64 also use PAC to sign and validate pointers cryptographically, and so on. Then next is the translation. So for the translator, this is more specific on the macOS. As we know, macOS can either be Intel or ARM. So what will happen if a user or application were to run in a whole another environment? Like an app compiled for Intel processor were to run in Apple Silicon. So this is where the Rosetta 2 comes in. I will give a scenario. So like when you click Intel base app, the kernel checks the file header. If it's only contain Intel instruction, it will prevent direct execution. But instead it will pass to the Rosetta 2, which will translate the instruction, the file, into ARM64. And then the app can launch like normal. And then finally, we got the flash size, the memory. So Intel using 4 KB, while ARM is 60 KB. So this will also be explained further later. And then, yeah. So we'll go back to the architecture difference. So Intel are using complex instruction set computing, CISC. The instruction has variable length from 1 up to 15. So this make the instruction pack. While ARM64 use RISC, the instruction are exactly 4 bytes length. So this make the assembly much cleaner and faster. Oh yeah, we go back first. So for this Apple Silicon, actually the latest one, which got they already published their cryptographic library, which mentioned that they are using PQC. So yeah, quite interesting. If anyone wanna go deeper, then can. And then yeah, this is the most fun part. Wait, alright. So this is the most fun part, the assembly. So here I put both the Intel and ARM assembly for you to see the difference. From the top, we are looking at the MOV. So this move to register to register. So both are using the same instruction. And then in ARM, I noticed that the different about the register before. ARM use X and number, while Intel like. And then in ARM, LDR, which is load memory, load from memory. And then next is SCR or store. So for this store, and only for store, the source register was on the left, while destination is on the right. So that mean the store X0 means store from register X0 and store it into the memory address, the X1. So not that this the source register only read for the store register. Other instructions still flows like normal, like from the right to left, but only the store is left to right. Right. Never mind. And then for the arithmetic, ARM64 use 3 operand. You can see the X0, X1, and X2. So for example, the X0 is actually the result of X1 plus X2. And then other arithmetic the same, just the operand. And then we got the control flow. Jump in ARM64 are called branch, and then the label for the unconditional. Then calling a function uses BL and then the function name. Okay. Right. And then for return, both are using red. And lastly, what are special in ARM64 that doesn't have in Intel? So you can see that in ARM64, there is STP, which is the store pair. So this is actually it took the current stack pointer address and subtract 16 byte, and then the add one. So for the add one is actually it multiplies the register X2 by 8. So how it goes 8? And by shifting the 3-bit multiply by 2. So it just become cut 8. And then store the final result in like 0. And then the compare and branch if 0, the CBZ. So this actually check the value inside register 0 and exactly if the program immediately jump, the code block. And if it's not 0, it ignore the jump and goes next the line. So this doesn't have an intent. Then we can go to what the exclusive in intent. So okay. Oh yeah. So actually in Intel in ARM you can like add directly from memory address. You need to load the memory first and then you can add. So it takes like a couple of um additional instruction. And then push and pop. So this doesn't have in ARM64. So it's using the I've given the store. And then yeah, we can. All right. So this slide is the most important part, the macOS file format. So in macOS, the normal application is actually a bundle. Like in comparison, it looks like APK. So it's a zip, but it's not zip. It's like a folder. If you ever read those one. So normal user actually saw the app, which is dot app extension. But the actual executable is actually inside the folder, the content and then the macOS. And yeah, if you try use the file command and the macro, it will shows like on the right side. It actually shows if the file got like two architecture, it shows both the ARM and 64. We cover later. And then um oh okay. Alright. So I will skip this since we got a more specific file structure. Yep. So yes, here you can see in the middle is the normal macro file which got the fat header. So fat header, the macro header, load commands and the data. So for this fat header, actually the one who handles which architecture to run. So either ARM or Intel. And then notice below that it got the repeated macro header, the load command and the data. So one is for Intel, while another one is for Apple Silicon. And then for the fat header, choose the slice that matches and then ignore the other. Like if the file, if the architecture is ARM, so it just load ARM and ignore the Intel. So we'll now decide the fat header to see how it works. It's on the left. First, from the fat header is the magic number to identify the file as a fat binary. So same like Windows got the magic number is called MZ. macOS got their magic number called it's a cafe babe. Yeah, it is what it is. And then it shows that it got two architecture inside the you can see that the fat architecture got two. Below is their respective structure, which we already explained before. it's got different size and alignment for memory, and yes, the offset. So for this offset, after it choose the architecture, offset is where the slice begin in the file. Like we'll go later. Begin the file, then the dynamic linker or call delete load the macro normally, which is on the right side, the right side. So the load command contains the oh yeah, contains the actual code. The data contain the actual code, which pointing where they at. So the segment pointing to where the data at. And then this segment is also tells where to map in the virtual memory. Um, right. So we can go next. So this one we already covered the memory layout. So I think the before one. So I forgot to mention. So like I mentioned earlier. So the segment tells like where to map in the virtual memory. So this data where contains the raw compile machine code is actually where is it? The data. The data is the data. I think not much to I already explained it. And then yeah. So this is the tools to reverse the macOS environment. So one of the famous one is Hopper and IDA Pro, which is all paid. But Hopper is free for like 30 minutes. Each session. Then it kicks you out. Yeah, so Ghidra all the way. Then next we got the LLDB for debugger. So I explain later debugger. Got the quite interesting fact. And then Otool. So this comes from the Xcode. So you can just this is under developer tools, and then the strings. Yeah, so same like Linux one. So you can just and then static versus dynamic analysis. So yeah, static as you guys know done the analysis without running. Oh yeah, so I wanted to highlight a bit about the debugger. So you can't just take any debugger and run in macOS, since macOS environment is sandbox, even even in user space. So LLDB is an exception since it was granted permission by Apple itself. So yeah, iOS also another case, which I'm not gonna talk. And then yeah, nothing interesting. All right, so for the workflow, start from the trash and then check file, then do Linux static analysis first. Then if not sufficient, then we proceed to the dynamic analysis. And then finally the reporting. So this is thing just yeah, just shows the how protected is the macOS environment. So the real use case, blah 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 blah. Got nothing interesting. Yeah. So for this challenge of reversing, for the obstacle, obfuscation actually is harder in macOS, not our as a reverser, but as a developer, it's harder since Apple is so strict about code signing. So if you wanna obfuscate after build it, it will break the signed binary. So yeah, every file after every file, if you wanna publish it on the macOS, it will have to sign the signing. So if you obfuscate after you build it, yeah, so it can block you from executing. So yeah, for obfuscation, usually developer obfuscate the code first and then build. Then the debugging, I've already this. Right. So key takeaways. Just it's a boring one. Never mind. And then uh, I think nothing. Okay. So I think we'll go. Yeah, we'll go into the demo. I forgot to run. Yeah. So I'm running under VMware. Can't see. Sorry. Forgot to share. Oh yeah. Mm, where is it? I can see right. VMware. So yeah, I'm running under VMware. So actually, you like can can just like put the ISO into the VM and then run. It cannot, since the Apple actually protected the environment. So you actually need to alter the VMware to make it seems like, oh, this is under Apple environment. Forgot to launch it. Uh, oh, so we'll launch Gitra. So for this file, I actually download it from Crackness. So yeah, if you wanna try, can choose the macOS environment and then the ARM64. Uh, so which one? Uh, let's see. Oh yeah. Yeah, I choose another one. We show you guys that yeah, this. So if a file got two architecture, it will shows that one is Intel, while another one is Apple Silicon, the ARM64. Yeah, I I forgot. So actually, I forgot the workflow. So actually, we gonna what uh do the cache first. So cd downloads uh sharing. Right. So yeah, as you can see, this is the bundle file. So it's just a folder actually. So if you check, it's yeah, show package content. Yeah, it's just a folder. And then while the executable file is under the macOS. Yeah, this is the macOS. cd check what content. Yes. Then if we go by file, the you uh, edit as license is if we go by file, yeah, it just shows is the macro file. Then yeah, interesting. Then we'll go back to the Ghidra. I'm just gonna don't want this. Want a license. Since the invitation party is like quite is using the LLDB, is I don't have it in this environment. So yeah, we can check that is a Apple Silicon, and I think it's yeah, we can check that it's under Swift. Oh, I forgot. For macOS actually got like two different what you call that programming language. It's either can be Swift or Objective C. So for Objective C is like a legacy language for macOS. Since the newest one are using Swift. Where's where's the file? Oh, I forgot. Should put it right. Mhm, 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 mhm. Oh, done. Analyze. Yeah, analyze. Oh, so I think one of the disadvantage is I think need to change the display. It's too small. Yep. Oh, sorry. We'll let it analyze first. Right. So done analyze. So we'll first check the function. So yes, if there's any fun of it. So this entry. Actually, in Swift, the entry is called main. Oh, but it's like mangle the wording. So yeah, we can try check the entry first. So entry got nothing. Can check the decompiler. So from this decompiler, you can see that there's NS application main. So this is on older or older. It's got on older iOS and iOS. So this one function is to call the Coco function, which it starts the UI, the GUI, and then yeah, from the entry just starts the UI and then exit. So nothing interesting. We then can check for the import. Yeah. Notice that it's all D lib, and then you got the key framework, so it's just all the GUI part. Then export. Never mind. We then check label thing. Oh yeah, we can now found the interesting part, which is the it use CryptoKit MD5. So now we know that the file or maybe the application running MD5 or like encrypt something. Wait. So yeah, app delegate. So I think app delegate and also view controller is almost on all the macOS and iOS, since this app delegate handles the app startup and also the view controller, which controls the screen, the button action, and so on. I think we can check in the view controller. Mhm. Just there's nothing. You want to check it in five or user action. So user action, we can take a look at what the program does. It shows like user action, maybe we input something or anything. So first is just import, and then uh, yeah, for this the scary 8 one, it's just like code increment, just like counter plus one and yeah, anything, nothing interesting. So I think, oh yeah, we got the string value here. So the view controller asks for string value. So it's a user input. And then uh, solution my bridge up. So for this, yeah. So for this one, the string, the view controller actually use the objective C. So it just like translate it back to the Swift. And then yeah, we know that the user input is now taken. And then now we just need to know like what is the User input. Mm, oh, this one. So this one just like yeah, from the user input, it takes the user input and then hash it by using MD5 and then store it on the this variable. I think we now just need to look at the variable the with oh yeah, you can see now that it's going to compare it with the v1. What is the v1? User string this. Oh, is the MD5. So is a store hash. So so it compare the store hash with the user input. If it's correct, then we'll maybe execute. So I think can check the metadata here. So it brings us to this. You can check this first. All right. So here is the just what it goes to the reference, and then like so our goal here is to like check. We now found that license MD5 is hard coded, but it's stored somewhere else. But now we know it's stored. We just need to find it in the data or metadata. Then for this is the metadata. Set. You can see that this is under license MD5, and then this is so yeah. This is all metadata. You can see that is the user input, tag button, counter. In, oh, invalid license code. I'm using it. Let's check. It's MD5, right? What about the MD5? Oh, so we check the hash. So yeah, the result is a secret key. So this is where I think if you are on, so since we are on crack me, so since this file is download from crackme, I think the result is the secret key, which after you open the file, it like requests you for maybe the user input to check if it's the same or not. If it's the same, then you get the flag. So yeah, this is the key. Yes. I think I want to show you the LLDB, but yeah, I don't have it. Don't. It's a dynamic punya, but never mind. Maybe we can do it later in another session, maybe. Alright, so I think yeah, that's all from me. I wait. Is this question? Wait, Macintosh and of course, what? Alamak, I cannot membesarkan you. I think I do try before, but where is it? Is it top here? Sorry, I didn't check the chat box. What the heck? Oh, why you doesn't say it earlier? Uh, Set the VM. My bad. What does the license app do? Yeah. So by looking at the flow, it looks like it just um take user input and then it compares with the store hash. And then after if it's correct, then it will maybe shows the flag, maybe the thing. And yeah, I don't know. I can't run it. It's not on the same architecture. Yeah, so by this using the Intel, since yeah, my host laptop is Intel, then how come it's become ARM? Yeah, I think you can do like your host is Intel, but you run an ARM, but it requires like other plugins to like translate Intel to ARM. But yeah, it requires very much resource and can make your VM lag. Is that the key for license apps? Yes, correct. Oh, yeah, sorry. How hard is it to reverse a macOS malware? So actually it's very hard since just to have a malware in a macOS environment is also hard. Yeah, for example, I do know like for iOS one is more like more strict since like what, yeah, all sandbox, and by jailbroken it you can just remove all the strictness. And then for macOS is a different. macOS like you can jailbroken it. It use the, like I said before, all the all the application here, even the mail, the Safari notes are all sandbox. So you can put any like any third party like debugger or something or to put it in there. Reverse. Oh yeah, I think I'm going far from the question. Yeah, for reversing a macOS malware, I think it's quite easy. Yeah, it's easier than Windows since like you know Windows got quite a lot of obfuscation and other thing, but in macOS it need to be like straight to the point. You can just uh, you can add like obfuscation or something. I think if you wanna try, can do the. It doesn't have much of punya this. Yeah, it just but can try. Just an easy one. Any more question? Kenapa tangan ke kaki? Oh, took me a second. I think you can create your own. Yeah, yeah, do the leg 64. Maybe 6, 7. Alamak. That's means we can do same thing like my process injection. Yeah, for this question, does macOS malware can do the same thing like Windows malware? Um, I think it can, but not like like what like what call it? Not as much as the I don't have the word. Wait, don't have much. Yeah, I think yeah. Oh, process injection. Process injection. Yeah. For if it's a process injection, then yeah, it can. For example, I do have yeah, process injection. I remove it. I don't have the sample with me. Wait, How did you demangle the Swift class just now? The one you show was already demangled, I think. Huh? Is it on the Ghidra? Oh, demangle the Swift class. Yeah. Actually, the Swift one. So your question is like Swift like mangle all the function, right? Then you ask me like mine is demangled. I think that depends on the program. But yeah, I also read supposed to be it's mangled. Mm, but yeah, actually this my VM current VM is new one. I don't have enough storage, so I just remove it. But for the sake of for the sake of this this sharing, I install it back. I think that's all for me. If wait, mana? Maybe in the future we can see uh, macro part in the CTF. Yeah, so I hope you guys can understand.